Okay, this is Algebra 1, Lesson 7.7. We're going to look at adding and subtracting polynomials. Let's start with our warm-up. So make sure you guys have tried all these before I show you how to do them, just to see if you're on the right track. So first one, we're going to add 4x plus 2x. So that means we can add these together because they are like terms. Since the x's have the same exponent on them, we're just going to add 4 and 2, and we're going to get 6x. For the second one, what's 3y plus 7y? Well, if I add 3 and 7, that is 10, and then we have 10 of those y's. 8p minus 5p, that is 3p, because 8 minus 5 is 3. 5n plus 6n squared. Okay, we cannot actually add these together because these exponents on the variable are not the same. So therefore, it's already simplified. We have to just keep it 5n plus 6n squared. We can't actually add them. Okay, number 5, to simplify the expression, we're going to distribute the 3. So we're going to get 3x plus 12. On this next one, number 6, we're going to distribute this negative 2 to both the t and the 3. So that's going to be negative 2t minus 6, because this negative sign times a positive is a negative. And then the last one, we're making negative 1 times every term. So basically, we're really just flipping the sign of every term. So now it becomes a negative x squared, a positive 4x, and a positive 6, because negative times negative is a positive times a positive is a negative. So today we're just going to look at adding and subtracting polynomials. I don't know what that little arrow thing is right there. There, it's gone. Just as you can perform operations on numbers, we can perform them on polynomials. So we're going to look at adding and subtracting them by combining like terms, which is kind of what we just did in the warm-up. So when we're adding or subtracting polynomials, we can only add or subtract the terms that are the same. So we need to find the p's to the third that are the same. So that means we add the 12 and the 8, and that becomes 20p cubed. And then we can't actually add the p squared because it doesn't have the same exponent, so that just stays. On this next one, we can add the negative 4t squared and the positive t squared. So a negative 4 and a positive 1 becomes a negative 3, because it's kind of like you're taking 1 minus 4 squared. And then these s squareds are the same. 2s squared minus an s becomes a positive 1s squared. We don't have to write the 1. If you want to write 1 out in front, you can. Okay. On this next one, there are no other x squareds, so that's going to just stay the same. We usually go in descending order, so we would go to our x's next. There are no other regular x's, so we're just going to make negative 3x. Now we can add the negative 6 and the positive 8. And that becomes positive 2, because 8 minus 6 is 2. Okay, so this next one, we've got to be really careful. We've got to find if there's any other m squared times n's that are exactly have that same thing. So here's one, and here's one. So we've got 10 plus 4 minus 8. So 10 plus 4 is 14, and then minus 8 becomes 6, and then we keep the term the same, so m squared n, sorry. And then there are no other m times n squareds. That's a different term. You've got to be careful because the squared is on the n, not on the m. So you've really got to be careful about that. So just remember, like terms are constants or terms with the same variable raised to the same power. If you forget this, go back and look at chapter 1, section 7. You can either add polynomials in a vertical form or a horizontal form. So in a vertical form, you just line up all the like terms like this and add them up. Or you can add them horizontally. Basically, you're just finding the ones that are the same and adding them together, which is kind of what we just did in the last example. So whichever way you feel comfortable with is fine. Okay, so in this case, we're adding 4m squared plus 5 to the m squared minus m plus 6. So I'm going to line up, in this case, I'm going to do it horizontal or vertically just so you can see. And I'm going to leave a space because there's actually no m here. So I'm going to put m squared below it. There's a minus m here and a plus 6 here. So when I add these together, that becomes 5m squared. Since there is no other m here, it's just a 0, so 0 minus m is minus m. And then 5 plus 6 becomes 11. Now you could have just looked and combined these and then combined these if you wanted. Whichever way you want to do it is fine. I'm going to do the next one horizontally. So x, y, I've got negative 3xy here and positive 10 here. So 10 minus 3 is 7xy. And then I have an x and a y. I can't actually add those. They're not the same. So those just get written down. Okay, so again, we're adding, cancel, I don't need an update right now. Okay, so I've got an x squared plus an x squared minus 8x squared. So 6x squared plus 3x squared is 9x squared. And then we take away 8 of those. So we're left with only 1x squared. You can write the 1 if you want. Now I've got a negative 4y, a positive 3y, and a negative 2y. What is going on? Sorry, guys. No, stop. Okay, sorry, I think I got that away. Okay, so where were we? Now we needed to add the negative 4y, the positive 3y, the negative 2y. Okay, a positive 4 and a negative 4 and a positive 3 become a negative 1, and then negative 1 and a negative 2 become negative 3y. So that's what we're left with. Okay, so on this next one, we're going to find our like terms. We've got a half a squared here and 3/2 a squared here. Well, 1/2 plus 3/2 is equal to 4/2, which 4 over 2 is 2. So that means we have 2a squared. Now our b's. We've got a positive b and a negative 4b. Well, negative 4 and a positive 1 become a negative 3. And then our 2 and our 5 add together to get 7. To subtract polynomials, where subtracting is basically the same thing as adding the opposite sign. So to find the opposite, you must write out the opposite of each term. So for example, if I'm subtracting this polynomial, it's basically putting the negative sign to every term, which just makes each term the opposite sign of what it was. So I like to rewrite mine like this when I have a subtraction. So 4y, and then I like to make this the negative or 2x cubed. So I've got x cubed plus 4y minus 2x cubed. Well, a minus 2x cubed and a positive x cubed become a minus 1x cubed, minus x cubed, same thing. And we're just left with the 4y. Okay, again, I'm going to rewrite this one. So I've got that. Now this is going to go to every term, and it's going to be the opposite. So it's going to be a minus 5m to the 4th, a positive 5m squared, and a negative 8. So now I can combine this m to the 4th and this m to the 4th and get 2m to the 4th. And then my 5m squared and my negative 2m squared become 3m squared. And then I'm just left with a negative 8. Okay, so again, subtracting, I'm going to write these out. I like to just write it out. If you drop the parentheses off, that's fine. However, again, you have to make sure that you change the sign of everything inside. So now I've got negative 10x squared and negative x squared. So a negative 10 and a negative 1 become negative 11x squared, minus my 3x because there's no other x's. And then a positive 7 and a positive 9 become a positive 16. Okay. Last one, 9q squared minus 3q. I'm going to distribute this so I get minus q squared positive 5. So now I have 9q squared minus q squared. So 9 minus 1 becomes 8q squared minus my 3q because there's no other q's and plus 5. Okay, so now we've got a word problem. A farmer must add the areas of 2 plots of land to determine the amount of seed to plant. The area of the first plot is this polynomial, and the area of the second plot is this polynomial. So we want to write the polynomial added together. So we're going to do 3x squared plus 7x minus 5 plus 5x squared minus 4x plus 11. Now we don't change the signs of any of these because we're just adding them together. So 5x squared and 3x squared become 8x squared. And again, we go in descending order of the exponents on the x's. So next we're going to do the regular, just x's. So 7x minus 4x becomes 3x. And then a negative 5 and a positive 11 become a positive 6. So that is the area of the land added together. Okay, so go ahead and pause the video and try these examples, and then I will give you the answers, walk you through them right now. So if you want to try them, that would be great. Okay, 7m squared and 4m squared becomes 11m squared, and then plus our 3m because there's no more to add. I need to distribute this, so I actually have a negative 5r squared and a negative 4s squared. So r squared plus s squared minus 5r squared minus 4s squared. The r's become a negative 4. The s's become a negative 3. Okay. Okay, I'm just adding, so I have 2pq here, 6pq, and 10pq. So all of that together becomes 18pq. And then I have a 3p and a minus 3p, or 5p, so positive 3p minus 5p becomes a negative 2p. 4d squared, since I'm adding, I don't have to change anything. And 6d squared becomes 20d squared. There are no other d's, so it's just minus 2d. And then I have a 1 and a negative 8, so that becomes a negative 7. Okay, on this last one, I'm going to distribute the negative sign, so I have a positive 1.5 AB minus 4B. I'm going to keep these the same. So 1.5 AB and 2.5 AB, remember I say kind of think of money. If I have $2.50 plus $1.50, that's going to be $4, and we've got to keep the AB. And then I've got 14B minus 4B, so that becomes 10B. So just a reminder, we can only combine terms that have the same variable raised to the same power, and you always want to simplify as much as possible, and that is